Welcome to Train Signal. I'm Chris Bryant, CCIE number 12933, and this is video 9, Multi-Area OSPF Part 2. And in Part 1 of the OSPF Multi-Area section, we built the following network. Let's take a look at that and refresh our memories just a bit about what we did before. Routers 1 and 5 are running RIP version 2. Router 5 has 3 loopbacks being advertised into the RIP domain. And on router 1, we have configured two-way route redistribution. The RIP routes are being put into OSPF, the OSPF routes are being put into RIP, so router 5 can ping anything on any of the other routers, any IP address. And we've got OSPF running over the cloud still, area 0, that's our core area. And we also have an area 34 running over an Ethernet segment that's connecting routers 3 and 4. And this is, at present, a total stub area. That's where we left off. So the only route that router 4 has right now to reach external and inter-area destinations is a single default route. So we're going to use this network to illustrate the route types that you have to know about for the BSCI exam, the router types you have to know about for the BSCI exam, and finally the LSA types you have to know for the exam. This is exam-centric material to a certain extent. You're not going to have many people walk up to you and say, hey, can you tell me which one of these is the ABR? You know, can you tell me what that OIA means? Because they're probably going to look in the routing table and be able to tell you, hey, here's what it is because here's what the code table says. But in the exam room, it's actually tougher than it is in a production network because you're not going to have the code table of show IP route to tell you what these routes are. It's also an excellent test to see who's actually seen it in operation and done it as opposed to somebody who's just read about it. Cisco exams are really good about that. So having said that, let's prepare to solve any question that Cisco asks us in that regard by taking a look first at the OSPF route types. And before we get started, you thought I was going to leave out route summarization, didn't you? But we're not. Route summarization is actually very simple for you at this point as a CCNA and a CCNP candidate. If you're a little rusty on your binary math, I'm going to fix that for you. And route summarization you're going to find is actually very simple when you understand how to convert just basic binary conversions to binary to decimal conversions. If you're comfortable with that, fantastic. Because what I've found is with CCNA and CCNP candidates, there's some hesitation about where to perform route summarization in an OSPF network. And it's not the easiest thing. I mean, calling this network back up, there are only certain places that we can configure redistribution here. We can't just do it anywhere we want to, and it also depends on what routes we're going to redistribute. And on top of that, depending on where we do it and what routes we're going to redistribute, the command can actually be different. If you're familiar with summary address and area range, a lot of people who are a little fuzzy on it think, well, I don't quite remember which one to use in which situation. This video is going to clear that up for you. You should solve every single route summarization question Cisco gives you when we're done with this video. You will be totally prepared for those. You're going to nail them. So, having said that then, let's take a look at our network as we go into a discussion of OSPF route types. And boy, that description just looks so innocent, doesn't it? Let's actually bring that back up. With OSPF route types, by definition, an OSPF destination network can only be in one of 3 places. It's either going to be in the same area as a router interface, it's going to be in another area, or it's going to be an external route. There really is no middle ground there. But it doesn't stay that simple. We've got some router codes that, frankly, you've got to memorize for the BSCI exam. I'm not going to sugarcoat it for you. You got to memorize these. You got to be able to look at these and say, okay, I know exactly what this means without any hesitation. So having said that, let's take a look at router 1. And we're going to look at the routing table there. And you're about to see why I like to run commands like show IP route RIP and show IP route OSPF instead of just looking at the entire routing table. Because our routing table here on router 1 is getting pretty big. We actually have to stretch out the screen here a little bit to even see the code table. So if you're looking at a table like this, where we have connected routes and OSPF routes and RIP routes, but you're only working on OSPF, those are the only ones you want to see, which in our case is the truth. Just run show IP route OSPF. That's not just handy for the exam, it's handy, period. Because looking, you can go blind trying to go into show IP route and looking at everything there. So we've got show IP route OSPF here, and we have one route marked simply as O. This is the only interface that I added between videos. This is another loopback that I created on router 3. I just named it 33 4 times. And this, I put it into area 0 to illustrate to you that this is what a route looks like when the router interface and the router and the destination are in the same area. And they're both in area 0. So it's marked simply with the letter O. And that's it. That's really all the letter O can mean. If we go back up and take a look at the code table, boy, remember when this code table used to intimidate you? And you'd look at this and go, oh, look at all these routes. Now you don't even worry about it. O just simply stands for OSPF. That's it. Now let's take a look then at the second kind of route on our board, OIA. And there's a space there in between the O and the I. It's a route to a destination in another OSPF area. That doesn't quite tell the whole story though, but let's look again at router 1's routing table, the OSPF table down here at the bottom. And what you'll see is, let me hit enter a few times. OP route OSPF. There we go, it's a little easier to see there. It's not scrunched up next to the other ones. What you're seeing here are 3 inter-area routes. The first one is to router 2's loopback, which is in area 2. The second one is router 3's first loopback, the one we've been working with throughout the course, 3333. That's in area 3. And finally, the Ethernet segment connecting routers 3 and 4. That's in area 34. Those are inter-area routes. So there's nothing complicated about that, but a detail you want to keep in mind on exam day. This is the router that we have in the total stub area, router 4. Let's look at the OSPF routing table. It has a single default route. That's what we expected to see. Router 4 is using this particular route to reach every single destination, inter-area, and external. Look at the letters, though. Don't just look at the asterisk. Look at the letters for it. It's O*IA. This is considered an inter-area route. It is considered an inter-area route, OIA. So don't just let the asterisk throw you. We've got actually 2 different kinds of OIA routes. One is for an inter-area destination network, and the other is the default route that your stub and total stub routers are going to have. Hopping back over to router 3 for a moment, show IP route OSPF. Here's the full OSPF table on router 3 at this point. And the reason I wanted to show you that is to keep in mind that the ABR that's involved in the stub area, it's not going to have the default route in its routing table. Remember from our network, I'll bring that back up. Router 3 is the ABR for area 34. That router will not have the default route. The other routers in the stub area will. So we've taken a look at regular old OSPF routes, and we've taken a look at inter-area routes, and you know now that that default route is considered an inter-area route. We're going to look now at external routes, and we've got 2 different codes, and boy, do you need to know what these codes mean. And it's not just for the exam. I can practically guarantee you're going to see something about these routes on the exam. But you got to know this for the real world too, because at first it's a little confusing. And we're going to bring this up. Actually, we're going to put a little drawing right here on the board to help you out with that. We're going to get rid of that though. What we have in our network right now we have router 1 here that I'm going to put in the center. And router 1 is running RIP and OSPF. We know that. So let's put a line right through 1, kind of representing the dividing point here. And here's a link to R5 that's running RIP. And here's a downstream link to R3. That's fine. We'll use R3. So here is our RIP domain. We'll put RIP v2. Here is our OSPF domain. Now we've got some loopbacks here on router 5 that router 3 knows about in its routing table. We'll bring that back up right now. Router 3 sees the loopbacks on router 5. They're right here in the middle. Not that 172.12.21.0. We're saving that for another lecture. But that 5, 6, and 7, and also the one on the bottom here, the 15, this is the segment that is connecting routers 1 and 5. These are external routes, and router 3 has a path to them, but they're marked as E2 routes. This is the default setting. By default, OSPF marks routes learned via redistribution as E2. The option, as we can see by running show IP route, the option here is to have them, there's the default E2. And the other option is E1. Now what this difference is that on R3, did you notice the metric on R3 leading to those remote destinations, those external destinations? It's 20, and that's the default. This metric does not reflect the cost of the path to the ASBR. An E2 routes metric is only going to reflect the cost of the path from the ASBR itself to the external destination. So when we've got E2 routes, the only thing that metric reflects is the cost between the ASBR and the routes being redistributed. It does not include the cost between router 3 and router 1. That's the default. They came up with it a long time ago before you and I came along, but I'm not that crazy about it. I would prefer my router 3 here to have a more accurate cost. And what we can do is make that route an E1 route. And when we have an E1 route, what that's going to do is reflect the cost of the entire path. We'll put it right there kind of to reflect that. E1 is going to have a different cost in the routing table, and the cost will be the cost of the entire path. It's much more accurate. So having said that, let's bring that up and let's see how we do that. I'm going to go back to router 1 because this is where the redistribution is taking place, and this could be a little tricky. So we're going to see how it goes here. Because sometimes when you perform redistribution, and it's another reason you really have to get your hands on the material, on the routers and switches, is that redistribution commands don't always come off cleanly, and we may see a bit of that right here and now. So what we're going to do with OSPF is configure, we're just going to try to write over it, the redistribute command, rip subnets, just as we did before. You can see that's exactly the command we used before. Let's use iOS help to see what our options are here. One of them is metric type. And notice next to metric type it says OSPF or IS to IS exterior metric type for redistributed routes. So we're going to type metric type here. And now let's see what our options are. 1 or 2 to set the external metrics. We're going to do that as 1. We'll put the connected ones in the same way. and we will see how this goes. No adjacencies dropped or anything like that, but notice two things right off the bat. First off, these routes that are being learned downstream are now E1 routes. We'll just highlight the corner there. They're now E1 routes. And then notice that the cost has changed. The cost was 20, now it's 84. That's because this E1 metric is showing us the cost of the entire path from router 3 to the external networks. It's a much more accurate metric, but it is not the default. But it's a good idea to know how to do that. And all we did was repeat the redistribute command with the metric type 1 on the end. Now the reason I was mentioning it being tricky, and this is real world what I'm about to discuss here. Sometimes when you're taking redistribute commands off or putting them on, but especially taking them off, this is going to sound strange, but the whole thing doesn't come off. You could type no redistribute rip subnets, and you know what your command would be in your config then after you saved it? Redistribute rip. Then you got to do no redistribute rip. You never want to take for granted that your config looks like you think it should when you're performing route redistribution. It's actually one of the things you really have to keep an eye out for. So that is route redistribution, and now we've taken a look at all of the route types. You know what an O route looks like. It's just a destination in the same area. You know now that an OIA route indicates a route to a destination in another OSPF area. And not only do you know what OE2 and OE1 routes are, you know the difference and why they show a different metric. That is a detail you must know on the exam. You must know that. So having looked at route types, we're going to take a minute to revisit something you really learned in the CCNA curriculum. We're not going to spend a lot of time with this. But these are the different OSPF router types. Some of these definitions, or actually all of the definitions, should look very familiar to you. The internal routers have all their interfaces in a single area. And in this network, did we have any internal routers? Let's bring up the drawing there and just take a look at that and identify the internal routers. And there are none. There's no OSPF enabled router here that has all its interfaces in a single area. Or is there? Router 4 does. Router 4 is now actually an internal router because we took the loopback off. We took the loopback off. So we've got router 4 there as an internal router. The other router we have to be concerned about is actually a backbone router. And a backbone router has only one interface in area 0. That's it. That's the only requirement. So we could have routers start to fill multiple roles here. We don't have any here yet. But obviously 1, 2, and 3 are all considered backbone routers. They have at least one interface in area 0. Now the two roles that we're much more concerned with are the ABR and the ASBR, because they come into play during route summarization, and obviously the ASBR is very important for route redistribution. But an area border router is a router that has one interface in area 0 and another in a non-backbone area. All ABRs are backbones, but not all backbones are ABRs. That's a key. So looking at our drawing here, looking at our network illustration, we have 3 ABRs, 1, 2, and 3. They are also backbone routers because they have one interface in area 0. If you're asked to identify router types in the BSCI exam, just be careful. You have to be kind of careful with that because it's really easy to look and say, okay, that's an ABR. But it could be an ABR and a backbone router. Finally, the one that I know you're very familiar with by this point is the ASBR, and that is the router performing route redistribution, and that is router 1 in our current network. So again, nothing earth-shattering here. You had this in the CCNA. You should be prepared to see a little of it in the BSCI. But you can also remember what command shows you what the roles are, and it's show IP OSPF. A lot of people forget about this command. There's a lot of good information in it, especially when you're getting into hardcore OSPF troubleshooting. And right here, though, simple enough, it is an area border router. And if we go up to router 1, we should see multiple roles being filled here, and we do. It is an area border and autonomous system boundary router. That's it. So those are the router types. When it comes to the LSA types, I would be very familiar with which types are generated by which router and what they mean. And we're going to take a look at some databases as we go around the network here, as we look at the different LSA types to illustrate what each one is. But I would know these cold, the LSA types. LSA, of course, is link state advertisement, and type 1 is generated by every router for every area that it belongs to. And these are flooded to a single area only. And the name, let's take a look at router 1 here, because I want to show you the name of these two. They're not going to be referred to by name. But the ones that we're looking at right there at the top, where it says router link states, these are type 1 LSAs. These are type 1 LSAs. And what they do, they're flooded to a single area only, and they contain the router link states for that particular router. Router link states, those are our type 1 LSAs, and those will be flooded throughout area 0 only. The one right under that, the net link states, these are sent out by the designated router only. These are type 2 LSAs. And since LSA types 1 and 2 are confined to a single area, this is another way that multiple area OSPF helps to reduce the load on the router resources. Because if you just had one huge area 0, every router in the area would be getting every single type 1 and type 2 LSA going around the network. So that's a type 1 LSA and a type 2 LSA. Good detail to remember for type 2, that those are sent out only by the designated router. Now type 3s and 4s are generated by the area border routers, but they represent different things. And let's take a look at that as we go down here. Let's hit the More button to bring that down a little bit. LSA type 3s, and here are the type 3 LSAs on our router 1. And these are generated by ABRs, and they describe inter-area routes. And they basically summarize the network from one area to another. But these are generated only by area border routers. Well, let's take a look further down in the database here, see what else we can see. So we've got router 3 down. Type 4s are generated by ABRs, and they describe the path to the ASBR. Very important detail there. Let's look at another router's database. This is where we're glad we have that algorithm, right? Because otherwise we'd have to take all these links and try to make something of it. Here is what those type LSAs look like. Type 4s. Summary ASB link states. And notice that link ID, it is mentioning, hey, this is the ASBR. So that's a type 4 LSA. So we've looked at 4 types here already. Type 1's generated by all routers, but that's the only kind that's generated by every router. Type 2 is by the DR for that segment only. Type 3 and 4 are both generated by ABRs, but you should know the difference in what they describe. Type 5 LSAs describe links external to the LSA domain. Let's see if we see any of those here. Hey, we do. And these are the LSAs that we're looking at right here. Notice that 5, 6, and 7, those are the loopbacks on router 5 being reintroduced or being redistributed into OSPF. As is 15, that's actually a connected route on router 1. But you'll notice that these type 5 LSAs describe links external to the OSPF domain. Good detail to keep in mind there. Now let's go down to router 4 and see what we see as far as type 5s go. Let's see if we, hey, that's it. This is another key feature of a total stub router, because you can see very quickly, this is it. This is as big as router 4's OSPF database is. It doesn't need anything else. And you'll notice that there are no type 5 LSAs in here, because a total stub or a stub area, they're not going to have those. They're not going to know anything about external routes. They don't need to. They've got that default route that router 3, the ABR for the area, generated. That's another good detail to keep in mind. Describe links external to the OSPF domain. That's what type 5 LSAs do. And if you have a router, such as a stub router or a total stub router, that isn't going to have any routes, specific routes, to those external destinations, there's a good chance it's not going to have the LSAs to begin with. We're going to discuss the bottom two here. I can't show you these two with the current setup, but that's fine. Type 6 is not one you're even going to see on your exams, most likely, but I want you to know what it is. I don't want to give you 1 through 5 and then 7, because I'm the kind of guy who thinks, well, what happened to 6? These are generated by a special type of multicast OSPF router. And again, it's not something you have to worry about yet. We're not even going to take it any further than that. I just wanted you to know what it was. And type 7 LSAs are generated only by an ASBR into a not-so-stubby area, or as we like to call them, not-so-stubby areas. What an NSSA is, a not-so-stubby area, it's an area that has been defined as stub, but it has some of the more specific routes rather than just the default route. And if that sounds kind of crazy, it is. I see them once in a while in production networks, but not that often. And you'll see some scenarios as you study for your CCIE where these would come in handy. But the key that you need to know right now is that these type 7 LSAs, they are flooded throughout a not-so-stubby area, but they don't leave that area. What actually happens is they're converted into type 5 LSAs and then sent out of the NSSA. So one more time, as far as type 7s go, the big detail to keep in mind, they're generated by the ASBR. They are sent into a not-so-stubby area and flooded throughout the NSSA. But type 7s never leave the NSSA. They are converted into type 5 LSAs and then sent out. Isn't studying for your CCIE going to be fun? And I don't say that sarcastically. It will be. But that's the kind of detail. This detail you don't need to know about yet. Just keep the general details in mind, and you will see some configurations as you study for your CCIE where you would bump into situations like that. We got enough OSPF to keep us busy right now. So let's take a look then at route summarization. Speaking of keeping busy, the first thing to keep in mind is that OSPF does not perform auto-summarization like EIGRP and RIP version 2 do. So we have no summarization by default going on. Now, OSPF stub areas and total stub areas, they help us keep that routing table complete and concise. That's what we're looking for. We want to keep it as small as possible. But it's also not always possible to configure stub and total stub areas. We can't make area 0 a stub. We can't make area 0 a total stub. And if an area is serving as a transit link, or excuse me, a transit area for a virtual link, we can't make that a stub or total stub. Remember in the previous video, we had to take the virtual link off of area 34 out of there so we could make that a stub area. But we still have opportunities to make the routing table smaller via route summarization. Now in your CCNA studies, you learned how to do this in RIP and EIGRP with the interface level summary address command. There are two ways to perform route summarization in OSPF, and the method you use, the command you use, differs according to what kind of router you're actually configuring them on. And the one we're going to see in action first is going to be the area range command. So tell you what we're going to do. We're going to bring this router up because you got to see this in action to really keep it in mind. And you'll actually get a chance to practice your summarization here too as well. So what we're going to do here, we're going to do a quick show config. It's always a good idea at this point to make sure we don't have any other loopbacks, and we don't. So we're going to add 4 loopbacks. And always check these whenever you're configuring them. I don't care if it's at home, I don't care if it's in a production network. If you start getting messages that, hey, this interface is now up, and you keep typing, which you get used to doing after a while, then always do a show config and make sure that they are there. Nothing to it. I cut the log messages off so we didn't get anything. Now we're going to put these networks into OSPF. And remember back when, you know, this would give you trouble? You didn't quite know the network command, and you didn't quite get the areas and all that kind of thing. It really is great to be able to pick this stuff up, because I was there. I mean, I remember that. I always swore as I climbed the ladder of Cisco certifications I would never pretend like I was one of these guys who always knew everything. Alright, so very quickly there, we added 4 loopbacks. We put them into OSPF, and we put them all in area 1. So right now, router 1's got 5 loopbacks in area 1. I didn't put them in area 0. Let's bring the router back up. And let's go down. We can always do a WR on the way out. Let's take a look at router 2. We haven't looked at router 2. It's probably feeling left out. And let's see. Down here at the bottom of all of this, that's a pretty big OSPF table by this point, isn't it? And here are the routes we just created. 8, 9, 10, and 11. What we can do to help bring this routing table down a bit is perform route summarization. And we can also do this with router 3. Now we can't shrink this routing table by making it a stub area, because we cannot make area 0 a stub. Don't let them throw that curveball past you at any point on your exam. You cannot make area 0 a stub. So what we can do is configure route summarization. And what we always come back to with route summarization is binary math. But that's not a problem for anybody here at this point. Let's take a look generally at the networks that we configured. Boy, summarizing these is going to be easy. Remember this when this used to scare you or bother you? Because it bothered me there for a while. Let's take a look. All we've got to do is break down the first octet into binary. That's 8. That's 9. That's 10. That's 11. That's it. So to come up with the summary, we simply work from left to right and draw a line where the 4 addresses no longer have a bit in common. And that's easy enough. We work from left to right, and we see that that point is right here. Right? Wrong. Wrong. I did that on purpose because it's a common error, and I know you're thinking, yeah, sure you did it on purpose. It's a common error with route summarization especially in the exam room, you know, maybe you're a little tense, maybe the clock's ticking. It's a common error to stop where the octets no longer have a bit in common, but people stop after the 1. They see the 1 and they think, okay, this is where they no longer have bits in common. Very common error. I'm not exactly sure why, but make sure you don't do that, because then it makes everything else you do incorrect. What we've done is drawn a line working from left to right where the 4 octets no longer have a bit in common. Well, to come up with the summary address, that's actually simple enough, because all we do is add up the value of the bits that are on the left side of the line. And it's 8. We know that the last 3 octets are obviously going to be zeros here. So we're certainly not going to draw up 24 zeros next to each one of those. So we have the summary address, but we don't have the summary mask. And the way you come up with the summary mask, and this is actually just as important as coming up with the address, your mask is going to have a 1 for every bit that the 4 networks have in common, and then a 0 for the ones that don't. So the first 6 bits here are set to 1, and you're already saying out loud, I know what that is in binary. And I'm sure you do. It's 252. Of course, the last 3 octets will be 0. So now we have our summary address. We have our summary address and our summary mask. So now, here comes the tricky part with OSPF. See, this is nothing to you now. You did that easily. Now we've got to enter the right command at the right point. And what we're going to do is bring router 1 back up. That's where the routes were in the first place. And what we're doing is configuring inter-area summarization. We're taking routes that we put into area 1 and summarizing them into area 0. So when it comes to the area range command, which area do we name in the command? iOS help isn't much help here. The number you put here is always the area where the routes reside. It's area 1. And then the rest of it is simple enough. That's one of those little details you have to watch out for, more on multiple choice than anything else. The number that you put in the middle of the area range command is always going to be the area that contains the routes being summarized. So we'll do a WR on the way out, go over to router 2, and see what the effect is. And do we have a summary route? We sure do. All the more specific routes now will be gone, or are gone. Yep. And here is the summary route. Notice that it is also an inter-area route. It's a good detail to keep in mind. We've actually seen 3 kinds of inter-area routes now. We've seen a regular route to a network in another area. We've seen the default route is marked as OIA when you've got stub and total stub routing going on. And also the summary route itself is going to be marked OIA. Good details to keep in mind. So now there's no problem with router 2 reaching those networks, but now we've summarized 4 networks into one statement. And there's no problem pinging any of them. And that's it. That's route summarization, inter-area route summarization. We've got one other kind to look at here, and that is summarizing external routes. Because right now, calling our network back up, router 5 has 4 loopbacks that it is advertising to RIP. Excuse me, just 3 right now, if I recall correctly. We're going to add one. We're going to add one just for fun. Let's go up to router 5. Anybody can summarize 3 routes. We're going to summarize 4. Let's see what we've got up here. We have the networks 5, 6, and 7. Let's add one to that. Let's add a loopback. We're going to add loopback 4. IP address 4444. And since we're running RIP, of course, to add that network command, and that's it. And we're going to clear our routing table dynamic, or with the dynamic routes. Do a WR on the way out and go down to router 1, see if router 1 sees it. You see what we're seeing right here with these asterisks? I'm glad this happened, because this is for you home lab fans. This is going to happen to you every once in a while, the way you save things on a Cisco router. This can happen to you in production as well. I've seen this plenty of times. I've actually gotten 2 a.m. calls saying, I was using Control-Shift-6 and now I just see these asterisks and I don't know what to do. Because we're on router 1. And we can type iOS help and it's not much help. And we can type help and now we're talking about some pad command. Now we're starting to panic because anything we put in, we could type help me and we get an error message. This is X25 configuration mode, and that's all you need to know about X25. But what you really need to know is if you remain calm and type the word exit right here and hit enter, it takes you out of it and right back into iOS configuration mode. So if that ever happens to you in a home lab or a production network, it happens when you're doing Control-Shift-6X a little too fast and you hit an extra key in there. It's very easy to do. I do it not regularly, but it happens. And you don't want to be the guy who doesn't know what that is. So let's go to router. We're on router 1. We'll run show IP route rip first off. And we see that this router by this point is seeing network 4. Let's see if our downstream routers are seeing it as well. Is router 3 seeing it in OSPF? Sure is, right there in the middle, an E1 route, because we configured redistribution to bring all the routes in as E1 routes. The administrative distance stays the same, but of course the cost is what changes. So let's see, now we've got 4 networks that are coming in via redistribution, networks 4, 5, 6, and 7. And we can summarize those as well. You've probably already done this in your head. Let's bring another one up. And you want to be a little careful about that. Because on exam day, when you're taking your BSCI exam, it's my prediction that time is not going to be a factor for you because you're going to know the material so well. Time only really becomes a factor when you have to think about a lot of questions that should just take you a few seconds. It never hurts to write this stuff out. I know that you could look at this and probably come up with a summary, but let's walk through it anyway. Binary string of 4, 5. Boy, remember when you thought this was hard? I'm never going to be able to do binary math. I hear that all the time. And 7. Working from left to right. Where do the 4 networks no longer have a bit in common? This time it is right after the ones. It's right there. How do we come up with the binary network, or excuse me, the summary network number? The value of the bits to the left-hand side of the line, which in this case is 4, and everything else is going to be 0. We know the last 3 octets are all going to be 0. We have to come up with a summary network mask. We look up here. Every single bit that is the same is represented with a 1. And every bit after that is a 0. And what's that going to give us? 252.000. That is our summary network, and that is our summary mask. That's the easy part. Again, with OSPF, we have to be careful where we actually configure this. And this redistribution has to be done on the ASBR, and that makes perfect sense because that's the router that's bringing the routes into OSPF to begin with. So let's configure, let's go to router 1 first. And under the OSPF process, the summary address command is applied. And remember with RIP and EIGRP, this was on the interface. It was IP, summary address, and then the name of the protocol. Not with OSPF. It's a router level command, routing process level command. And let's go down to router 3 and see if that is available yet. It's already there. So our downstream routers now have two separate summaries. And there's the summary. Notice the code on this one, though, is not IA, it's E1. The reason it's E1 is because that's the code of the routes being summarized. So that's not going to be IA, that's going to be E1. Good stuff to know. So just one more time, just keeping in mind, the summary address command is going to be used on the ASBR to summarize routes being redistributed into OSPF. And the area range command is the command we're going to use to perform inter-area summarization. You cannot perform route summarization between two routers in the same area. There's no command that's going to allow you to do that. And to wrap the OSPF videos up here, we're going to revisit an old friend on router 1, show IP protocols. The deeper you get into route redistribution, route filtering, altering administrative distance, altering the metric of a route, which you're going to do as you progress up the ladder toward that CCIE, you're really going to want to keep revisiting show IP protocols. People just forget about this command. But now we can actually see what routes are being redistributed into RIP and OSPF. We can see all kinds of things. Of course, you remember from earlier that we can see what version of RIP we're running, what routes, what the routing information sources we have, what networks we're routing for. You can also see here whether the router is an ABR, an ASBR, or both. You can see that we are redistributing connected routes and RIP routes into OSPF, including subnets. So there's some fantastic information here, and as we wrap up OSPF here, I would just remind you this one more time. You're going to learn more and more OSPF commands as you pursue your studies. Don't forget about show IP protocols.